Hello dear student boys and girls, this is Dr. Khaleel Khan welcoming you to Geeks for Geeks, and I'm very happy to inform you that we are going to start with operating system academic series, where the objective is to basically deal with operating system course for multiple purposes. Now this course, boys and girls, will not only be useful for preparation of GATE and other competitive exams like ISRO, BARC and others, plus it will also help you for writing semester exams. Okay, and not only semester exams, I would also like to say that this course, if you try to follow my videos, will basically also help you from placement perspective. So keeping in view of all these perceptions of GATE, other competitive exams and semester exams plus placements, I am going to make a discussion on this. So we are going to cover almost all the subjects. Okay, these videos will cover up all the topics. I'm sorry, not all the subjects, all the topics of operating system course. So let's begin our discussion. So in this lecture 1, we are going to focus on the introduction and background. This is a brief profile about myself. I have around 30 years now of teaching experience, with more than 25 years dedicated experience to mentoring GATE aspirants. And I have 30 publications, 50 publications in various reputed articles, journals, and I deal with courses like operating systems and algorithms. So presently, I'm a mentor and tutor at Geeks for Geeks. Okay, so you can scan my personal profile on Telegram channel, and this is the Geeks for Geeks QR code. So before I start, I would like to make a disclaimer or an important note. Please observe that the slides and the content that I am taking here is from the instructor resources. Boys and girls, this is important. From the instructor resources of the textbook by name Operating System Concepts, 10th edition by authors 𝐂𝐨𝐬𝐿, Galvin and Gagné from Wiley Publications. The content is not copied from any other source. So the whole course will be based on the instructor resources, that the slides provided by the authors 𝐂𝐨𝐬𝐿 and Galvin, who say the instructors can use it for their delivery, content delivery. Okay, so that is the disclaimer or the note which I would like to tell. And let me just briefly tell you all the topics that we are going to cover up as far as the course is concerned. Briefly, I will write the topics so that you can have an idea. I divide my course into the following topics for your ready reference. Okay, so first topic will be introduction and backdrop, or the background you can say, where I will tell you what exactly operating system is and what operating system can do, what are the functions and goals of operating systems, the types of operating systems, and essentially we focus on multi-programmed operating system, multitasking, both preemptive and non-preemptive. And we also will look into some computing environments, the computer architecture. So essentially all the concepts, all the foundations which are necessary for building up the later topics. That will be covered in introduction. I basically plan to cover up this introductory part in two parts, in two phases, part 1 and part 2. Okay. And secondly, I would focus on system calls. What is a system call and what is the purpose of system call, and how system call is implemented. Plus, we would also see the services in general that are provided by operating system. Essentially, the difference between application program, system call programming, all that will be covered here. Okay. And then third part, the third module will be on the process concepts. So I'm basically aligning my lectures exactly as per the content of Galvin textbook, so that nobody should have any kind of doubts as to where the content is being taken from. Absolutely from the textbook of Galvin. The slides and the content provided by 𝐂𝐨𝐿 and Galvin in their textbook, Operating Systems Concepts by Galvin. Okay, process concepts, where the intention is to learn what is the difference between a program and process, right? And what exactly is a process, how is it different from a program. Then related issues of process like the process states, the process attributes, the state diagram, queues and queuing diagram. So all the relevant things will come under process concepts. Then the next chapter will be on CPU scheduling. The need for CPU scheduling. Why do we require CPU scheduling? Right? Different scheduling algorithm, first come, first serve, round robin, priority, shortest job first, all that will be covered here. And then a small topic on threads and multi-threading. What is a thread, types of thread, benefits of thread, all that will be covered. Then essentially we move into synchronization. What is synchronization, need for synchronization, and the study of various synchronization techniques, various synchronization mechanisms. Followed by related issue of synchronization, that is called deadlock. So this is, boys and girls, let me tell you that this cover basically what you call under the topic of process management. If you name process management as one module, so all these will be covered under process management. All these are the various chapters that comes, excepting for the first two topics. Remaining all are basically related to process concepts. Okay. And then the second module of operating system, essentially as far as the Galvin textbook is concerned, what we are going to focus is memory management. I would say memory management techniques like contiguous allocation, non-contiguous allocation, and swapping systems, right? Overlays, all that will be covered under different memory management technique, contiguous and non-contiguous. We talk about partitions, we talk about fixed partitions, variable partitions, and then we also talk about non-contiguous allocation like paging, segmentation, segmented paging, and so on. And a related issue of memory management, which is of prominence and very well discussed in, very well covered or used in contemporary operating systems, and that is called virtual memory. Popularly written in short as VM. What is virtual memory, how virtual memory is implemented, okay, and what are the performance issues related to virtual memory. Then followed by that, the last module is file system. And in file system, we will essentially focus on implementation part, file system implementation. So boys and girls, this is how we divide the syllabus. So this is memory management, this is file system, three important core modules of operating system, exactly as per the syllabus of GATE and other competitive exams, plus, as I said, semester exams. So again, I am re-emphasizing again and again, the content that we are going to learn, the subject that we are going to learn here will not only be useful for GATE and other competitive exams, your semester preparation, and also placement perspective, interviews perspective, all this will be useful. So the content I am going to design to cater to these requirements. Okay, and as I said, the contents are borrowed from, I am predominantly referring only the content or the instructor resources provided by Galvin textbook, Galvin and other authors. Fine. So in respect of that, let us begin our discussion with the first module, introduction and backdrop, or introduction and background. As I said, we are going to look into what exactly is operating system and what operating systems can do, so that you can have a clear idea as to what exactly an operating system can do, and you should have an extreme clarity as to the definition of operating system. Come on. So as you know, the most prominent common definition that you find in the textbook of Galvin and other resources is a program that acts as an intermediary between a user computer and between a user of the computer and the computer hardware. So boys and girls, there's an important word that you need to understand here is intermediary, or sometime even you call this as interface. Interface. That means, for example, imagine this is some user like you and me, and let's imagine this is some computer hardware, and in between them we have the operating system core. All right. So this is the operating system as an interface between user and programmer and the computer hardware. Okay. Now we need to briefly understand what is the necessity of this intermediary or interface between user and hardware. Let us briefly try to decode and understand this. See, the language that is understandable by the hardware, as you know, is a language of binary 0 and 1. And the language which is used by user and programmer is a high level language that is normally like English A to Z. So this situation is to be imagined like two different people using two different languages. I use one language, the system use another language. So if we wish to converse, there will be incompatibilities, there will be synchronization issues. So therefore, to harmonize the differences between me and the computer hardware, I need this operating system. So operating system taking the charge like an interpreter, taking the commands in high level language from user and programmer, getting executed, transforming them into the language understandable by the hardware, getting executed, and then provide the result back to me in the form which I can understand. So that is the basic objective of operating system. So boys and girls, operating system is a pure software, it is not hardware. It is pure software, it is called system software that sits between user and programmer and the hardware. Now here comes a simple question, what exactly is the hardware and what are the important components of it? So the important components of the hardware essentially, as you know, depends on the underlying architecture. The most prominent architecture that we use for our desktop and laptop is JVN architecture. JVN, I mean John von Neumann. The architecture which is used in the normal desktop and laptops, JVN architecture. And you know very well what are the important components of the JVN architecture. The important components, as you know, is the processor, the memory, that is the primary memory, RAM, and the input output devices. And the JVN architecture, as you know, follows stored program concept. I'm briefly telling this. Stored program concept implies that any program that you wish to execute must be present, must be stored in memory. Any program, right? Machine language program, low level language program of C or C++ or Java or any other language, if you wish to execute, it must be stored in memory. No program can directly get executed by the processor from the secondary or a tertiary storage. It should be in main memory. That is called stored program concept. So after loading or storing the program in memory, how does the program execute on the CPU? It is executed purely on sequential basis. That is called sequential flow of control. Instructions are executed on sequential basis. That means I execute the first instruction followed by second, followed by third, followed by fourth, following instruction cycle. Instruction cycle involve fetch cycle, decode cycle, operand fetch, execute, as you studied in the subject of CO. As you know, the prerequisite for this course, operating system course, is a good substantial knowledge of computer organization and digital logic, and superficial knowledge of programming in data structures, not in depth, superficial. Then you can pursue the course. So that is about the hardware. So what we are trying to say that in the absence of the operating system as a software, then the user and programmer like you and me will have to operate on the hardware directly, which is very cumbersome, which is very, very tedious and not an easy task. So therefore, I place operating system as a program, as an intermediary between the user and the hardware. So the job of operating system is to take the charge, take the control of the hardware and create a platform environment for users like you and me, so that we can focus on our application development in the high level language, and the operating system will create a platform for me to execute my programs. So that is the basic objective. So invariably, as a consequence to this definition, I may not be wrong if I say, acting as an intermediary, operating system create an environment, a platform, create an environment. Or I may not be wrong even if I say it creates a sort of ecosystem, so that we can focus on our application development rather than managing or worrying about the hardware. So operating system manages the processor, manages the memory, manages the input output devices, and create a platform environment to us, so that we can focus on our application development rather than worrying about the management of the hardware. So for that, it includes several modules. Like as I said in my syllabus, process management means the job of the process management module is to take the charge of the processor. The memory manager is responsible for managing memory. The file manager and device manager is responsible for managing secondary storage and other IO devices. So that's how the operating system is organized. So boys and girls, operating system is not a single program. It is rather a collection of modules, collection of segments, right? Modules, we can say layers, which is responsible for managing various units of the hardware. Okay, so all these modules, the core modules of the operating system, process manager, memory manager, file manager, device manager, and there are other things that are going to come up at later point of time. All these make what is called the kernel of the operating system, the core part of the operating system. So essentially, we can say operating system will have two layers, two interfaces. Listen to this. If I try to project this in the form of a diagram, the form of a block diagram, it may look something like this. At the lowest level, we have the hardware. That includes your processor, memory, and input output. Okay. And above that, we have what is called the main operating system core. So here we call this as operating system kernel, which is the main core part of operating system that basically takes the complete charge of the hardware. It includes process manager, memory manager, device drivers, interrupt handlers, all that makes your operating system core. And over and above, if you imagine users like you and me, like here we have users and programmers like this. So as you know very well, when we are working on the system, users and programmers, so let me write, these are users and programmers like you and me, right? Like user 1, user 2, and programmer 1, programmer 2. So users and programmers will not be interacting with the core module directly. So that means between the user and programmer and the operating system core, there is another layer of interface, intermediary. And this is called level, I will call this as level 1 interface, level 2 interface. Together level 1 and level 2 make the definition of interface, intermediary. Okay. This is called user OS interface. An interface that allows you to communicate, that allows you to talk to the kernel. Like this could be including, for example, from your previous knowledge, if you know system call. For programmers, it is system call, and for normal users and programmers, it is called the command interpreter. It is called command interpreter. A program that interprets the commands given by the user and programmer so that they can get executed on the machine, on the hardware. So this is an abstract view of the computer, making the definition, profound definition of operating system as an intermediary between user and hardware. So this is the meaning of the first definition, intermediary or interface. System call is a mechanism by way of which you can you can avail any operating system service from the user application like C, C++ program. And command interpreter is a program through which the users, without using programming, they can type the commands, they can use the graphical interfaces like desktop, etc. to communicate with the operating system. Okay. An example of command interpreter may be either shell for text-based operating system, or for GUI-based operating system, it is a desktop application. Is it not? So that is the command interpreter. So that's how we basically try to project the definition of operating system. The important goals of operating system, the primary goal is to allow the users to execute their programs and solve the problems easier, convenience. Make the computer system convenient to use, that is the primary goal. Secondary goal would be efficiency. Secondary goal would be efficiency. So primary goal of operating system is convenience, and secondary goal of the operating system is efficiency. Efficiency implies the effective, efficient utilization of resources. The processor should not be wasted, memory should not be wasted. All right. So that is about the efficiency aspects. Fine. So that is about the important. The other definitions of operating system you can project, like we can view operating system as a resource manager. It is managing the hardware and software resources. Some people even call operating system as a control program, a program that controls all the operations of the various units of the computer system, control program, right? And some people even they visualize like operating system functions or acts like a government. It acts or functions like a government. Just like government has several ministries or cabinets taking care of various functionalities, various resources of the country. Human resource, Ministry of Human Resource, Ministry of Railways, Ministry of Agriculture, Ministry of External Affairs. So like that, operating system also has several cabinets and ministries. Just like no one minister, no one person is government, is the government, right? Is part of government. Exactly like that, there is no one single program which is operating system. Operating system is a collection of programs. It is not that one single program will act as operating system. It's a collection of programs. Just like no one person is government, exactly in the same way, no one single program can be treated as operating system. Fine, let's go to the next. Now, a brief review with regard to the computer system structure. First, at the lowest level, just now as I said, we have the hardware that provides basic computing resources like processor, memory, and I/O devices. Then over and above, we have the operating system core and kernel, controls and coordinates use of hardware among various application and users. And over and above that, we have application programs written by us like C++ program. It can be word processors, compilers, web browser, databases. These are all application programs. And over and above them, the users, people like you and me, or it can be machines also and other computers who will be treating or using the operating system. And this view you can see in this form. So I have the computer hardware, the operating system core and kernel, and the application programs, and used by users. This is what is called the abstract view of the whole computer system along with operating system. Essentially, what operating systems can do, what is the functionality, what exactly is the perception of the user or programmer as far as operating system can do. It all depends on the viewpoint of the different types of users and programmers, right? Users don't care about the resource utilization. What they want from the user perspective, we want convenient use of, or convenience, you can say, ease of use and good performance. But shared computers such as mainframe or mini must keep all users happy. So just now I said operating system is essentially a resource allocator and control program, both the definitions I gave just now, right? And users of dedicated system like workstations have dedicated resources but frequently use resources from servers. Mobile device, so the perception changes from different computing environments as to what operating, like for mobile environment, what should the operating system do, right? So run primarily without any user intervention, that is the operating system. So because of myriad means many numbers, designs and uses of operating system, right? And the roles of operating system may change from the deployment where the operating system is made in different kinds of devices. And therefore, finally, I would like to make a mention as per a very famous statement of Galvin that there is no universal definition of operating system because of these myriad designs and applications of operating system used in different computing environments. So there is no universal definition because different people working in different environments and using the operating system, they visualize operating system differently. So therefore, that's what I have highlighted here. There is no universal definition accepted. It's a program that runs all the times on the computer, right, which is called the kernel, and that is the main core part of the operating system. That is 24/7 running when the system is up. Everything else is either a system program, right, an application program written by you and me like our C++ program, word processors, browsers, etc. So typically operating system for general purpose and mobile computing also include middleware, a set of software frameworks that provide additional services to application developers. So I can have other middle layer softwares also, like as in the case of mobile devices and others, to facilitate the user applications. Okay. Now brief review with regard to the computer system structure of JVM architecture, even though I've already told, but just glance through the slides. So this is the typical view of a computer system operation of a JVM architecture, John von Neumann architecture. Okay. I may have one or more CPUs. So here in this I have one CPU, as you can see here, and then the device controllers, disk controller, USB controller, graphics controller through common bus. This is a common bus which is connecting all the devices, right? So actually this line should extend here also. And concurrent execution of CPUs and devices competing for memory cycle, because this is a shared bus. So therefore there may be some competition or contention involved as far as the sharing is concerned. The processor may try to access memory, the disk may try to access, and other devices also may try to access memory. So therefore that is going to bring in some contention which has to be resolved using some protocols. So this is a brief review with regard to the function of each of them, right? So this is already done. You might have already studied in your basically the subject of computer organization. Next, interrupt is again a very important aspect in the implementation of operating system, because as you know very well, boys and girls, operating system is purely interrupt driven. Interrupt is like a signal. Like for example, I am taking the class, I have closed the door, somebody knocks, that's an interrupt. So I may momentarily pause the class and then I attend the interrupt and come back. So like that, in the computer system also, there are different types of interrupts: hardware interrupts, software interrupts. Interrupts that are generated from the devices are called hardware interrupts, and interrupts that are generated as a result of execution of program instruction, that is called software interrupts. So whenever an interrupt occurs, it transfers the control to the interrupt service routine. Popularly we call it as ISR, through the interrupt vector, that is an array. which contain the address of all these service routines. Interrupt architecture must save the address of interrupted instruction. That means the program which currently was executing, we have to save the instruction to serve the interrupt, and then again I can come back and resume. Sometime interrupts are also called a trap or exception. Generally that is a software generated interrupt which is causing or caused due to an error condition. So we use the word trap or exception generally to indicate an error condition, particularly when we are executing any instruction. So as such, as I mentioned just now, you have to keep in mind that the whole of operating system is purely an interrupt driven. It is purely interrupt driven. So interrupt occurs, we service, we attend to that interrupt, we service the interrupt again, we continue. The operating system preserves the state of the CPU by storing the registers and the program counter when an interrupt occurs, determines the type of interrupt, and separate segments of code determine what action should be taken for each type of interrupt. So this is all the review, basic review, short review with regard to what you studied in the subject of CO. This is what is being explained, what I said just now, right? So this is a processor. After executing any instruction, it will check for any pending interrupts, and therefore it takes the action and again go back and continue. So these input output controller states when for interrupt driven. As you know, there are three modes of transfer. One is program control transfer, the other is interrupt driven transfer, and the third is DMA, direct memory access. So this is what is talking about interrupt driven transfer. So generally there are two methods for handling input output. As far as input output is concerned, after input output starts, control returns to user program only upon IO completion. This is called synchronous. This is one approach of dealing with input output. The other approach of dealing with input output is after IO starts, control returns to program without waiting for IO, asynchronous. Is it not? I don't wait. I just basically continue. It is not synchronized with the interrupts mechanism. Now coming to the third module of the computer system architecture, which is a very important one, memory. Memory is organized as a linear array of words. Every word will have an address. Every word will have an equal size, width or length or size of word. Memory is specified as number of words by width of word. Total number of words are some x. Width of the word is some n. So therefore x by n is the memory specification. In regard to memory storage, there are two types of storage, primary and secondary. Primary is volatile, costly, faster access. Secondary is non-volatile, persistent, like hard disk, DVDs, cartridges, etc. And it is slower to access. Generally, the order of access time of main memory is in nanoseconds, and that of secondary storage is in milliseconds. So let's have a quick review with regard to various aspects of this storage structure. So just now, as I said, main memory, primary memory, basically only large storage media that the CPU can directly access for random access, and typically it is volatile, right, in the form of dynamic random access memory, DRAM, and secondary storage, which is an extension to main memory that provides large non-volatile storage capacity like hard disk. Okay, hard disk drives. And this is the view, this is the details of the hard disk controller. You can just go through the content, go through the points with regard to non-volatile memory, that is the hard disk. And here I have some important terms that you should note. The basic unit of computer storage is the bit. Bit is either 0 or 1. Then you have something called a byte. Memory is generally measured in byte. Byte is a group of 8 bits. And most computers, the smallest convenient chunk of storage is a byte. Okay. Most computers don't have an instruction to move a bit, but one or to move a byte. And word is made up of one or more bytes. So boys and girls, there are three important terms. One is bit, which is related to storage. One is bit, group of 8 bits, 1 byte, and a group of one or more bytes is called word. A computer executes many operations in its native word size rather than a byte at a time. That is another point. Execution of instructions may be in the form of words. That is what we are trying to say. Okay, and the measure of unit of memory generally is in kilobytes, KB, which is 1024. Kilobyte is 1024. Megabyte is 1024 into 1024. Okay, look at that, 1024 square. Gigabyte is 1024 power 3, 2 power 30. Terabyte is 2 power 40. Petabyte is 2 power 50. Computer manufacturers often round off these numbers and say that a megabyte is 1 million bytes and gigabyte is 1 billion bytes, like that. Okay, so that is very important. So it is generally the storage systems are organized in the hierarchy of speed, cost and volatility, right? In this order we basically organize the secondary storage. Caching implies basically copying information into a faster storage system from main memory in cache, or from disk into main memory, that is also caching. What is a device driver? For each device controller to manage the IO, I have a software by name device drivers, okay, that provides a uniform interface between the kernel and this. So this is the memory hierarchy, you can say. So this is smaller in size, this is larger in size. Registers, which is the fastest to access, followed by cache memory, followed by main memory, non-volatile memory, hard disk and other things, okay. So that is super fast and this is super slow. And this is a table illustrating the levels of the types of memory, types of memory: registers, cache, main memory, solid state disk, magnetic disk. The parameters of the relative comparison of them is typical size, implementation technology, access time, bandwidth, that is the speed, managed by whom and backed up by what. So boys and girls, I would suggest this is an important table which you can mark it for reference at a later point of time, right? You can pause the video, take a snapshot and make a detailed study about this. I am not going to talk about all this because this is part of your computer organization, okay. And next, before I come to this slide, I will just would like to talk about the next topic, which is called types of operating system, okay. Categories of operating system, types of operating system. Let's focus on that. So let us write. So as I said, the most important topic, one of the important topic as far as exam is concerned, or even you can say from gate exam perspective or semester exam perspective, is an important aspect. What are the types or categories of operating system? Basically, the categorization or types of operating system you have to see from the perspective of evolution of computer systems. Like in first generation of computers, second generation, third generation, the evolution of computer systems and correlation to operating system, okay. Essentially, I can say during the first generation of operating system, the first generation of computer systems, there was no OS. During second generation, there was no OS. During third generation, with the coming up of disk technology, with the evolution of disk technology, only that the two major types of operating system evolved. What are the two types? As you studied, as you know perhaps, one is called uniprogramming. And the other is multiprogram. Now this is primarily very important. Uniprogrammed and multiprogrammed. What is uniprogramming? The ability of the operating system to hold and manage a single sequential user program in memory is called uniprogramming. So boys and girls, I would like to emphasize this definition by taking a suitable example. Check on board. Imagine this is memory. Generally, we divide the memory into two parts. The one part is meant for storing operating system. This area is called system area. And the other area is called user area. So in this user area for uniprogrammed operating system, I will load a single program into memory. That is called uniprogramming. Then sir, what about the other programs? The other programs are stored on disk. So here I have program 1, program 2 and so on. Disk may have multiple programs, but operating system will have the capability to load and manage, execute single sequential program. If the program present in memory runs on CPU, our objective is served. But problem will happen when the running program will relinquish the CPU for performing IO operation. The moment this program relinquishes the CPU for performing IO operation, the processor become idle. So thereby we can say the major setback or the major drawback of uniprogramming is idleness of CPU. Idleness of CPU. One program is not sufficient enough to keep the processor and the IO devices busy. So this problem can be overcome only when I have in the operating system, in the computer system, multiple ready to run programs in the main memory. Okay. So we divide this again into two parts. One part meant for storing operating system as usual, and the user area will be broken down. User area will be divided into different programs, or different programs can be stored in different parts of user area. So here I can say I have program 1, program 2, program 3, program 4. This is the memory view or the memory map for a multi-programmed OS. The ability of the operating system to manage multiple ready to run programs in memory is called multi-programming. Why should I have multiple programs? So that if the running program relinquish the CPU, leave the CPU for going for IO operation or execution of any system call, the processor can be switched to another program. So that's why it is sometimes also called multiplexing of CPU among different programs. It is just like you have to imagine the processor is shifting from one program to another program, so that the processor can be kept busy most often. So essentially I say that the basic objective of multi-programming is to maximize CPU utilization. By maximizing CPU utilization, throughput will increase. So it has direct impact on the performance metric, throughput. Throughput is defined as the number of programs, number of processes completed per unit time. So it will maximize the throughput or efficiency of the system. So that is about multi-programming. So as you studied perhaps in the literature, that multi-programming is of two types. One is called non-preemptive and the other is called preemptive. Preemption means forceful deallocation. Non-preemption means no forceful deallocation. Running program will not be forced by the operating system or any other external event to preempt the CPU. That is non-preemption. Non-preemption will have the drawbacks related to starvation may happen. That means lack of interactiveness, lack of responsiveness. So go for preemption. Forceful deallocation means the program not only will release the CPU on its own, but can be forced by the operating system to release the processor, maybe by means of time or by means of priority. That is called forceful deallocation. At the outset, I would like to mention that example of uniprogrammed operating system is the first operating system from Microsoft, disk operating system DOS. And the contemporary operating system that we use here, Windows, Linux, Mac, all these are basically multi-programmed in nature, which is preemptive based multi-programmed OS. Okay. So that's what here, multi-programming organizes jobs or program which consists of code and data. So CPU always has one to execute. Okay. Of course, that is job scheduling we'll see at later point of time. These also will see what is response time and then virtual memory concept, interactive computing, all of that. The typical view of a memory layout for multi-programmed operating system, which I have explained to you just now. Okay. And now one of the important, I would like to make a mention about this shortly. All right. In respect of this, I would also like to make a mention with regard to the term that we generally use called multitasking. Okay, you might have encountered this word particularly in the literature of Microsoft. They claim their operating system to be multitask. Multitask essentially and effectively in essence is nothing but preemptive based multi-programmed OS. Preemptive based multi-programmed OS, multitask. So essentially multi-programming, multitasking, all you can say are same, because process, task, these are basically synonyms. Jobs are synonyms. Okay. And one of the important aspects in the implementation of multi-programming is the support needed from the processor. What kind of support in general is needed for the implementation of a multi-programmed operating system like Unix, Linux and Windows? I need DMA support, I need address translation from memory, and predominantly from the processor side I need dual mode operation. Every processor we say should support two modes of operation. One is called user mode and the kernel mode. All operating system, all application programs, right, C++ program written by us, right, all these basically all the application programs, so C++, Java programs, etc., they run in user mode. Whereas all operating system routines, operating system programs, they run in kernel mode. User mode is preemptive, kernel mode is non-preemptive. That is also called atomic. Atomic means without preemption. Of course, we have the concept of preemptive kernels, but I don't want to enter traditionally non-preemptive kernels. Preemptive kernels we are not going to talk about. So essentially, as per the old architecture, we are that is the orthodox type, we are basically talking about non-preemptive kernels. So that is what is dual mode operation here, we say. Allows operating system, and that dual mode is basically for the purpose of protection from unauthorized access by user applications and try to manipulate the operating system kernel data structures. The mode bit present in the hardware is basically going to distinguish in which mode the processor is executing, user mode or kernel modes. So it provides the ability to distinguish when system is running user code or kernel code. When user mode is running, mode bit is set to user, and when kernel code is executing, then it is set to kernel. That is 0 and 1, something like that. Okay. System call changes mode to kernel. That means whenever sometimes as a user I want any operating system service, those services have to be accessed through system call. The word system here refers to operating system. A call to operating system for availing operating system services. So essentially, whenever I activate a system call from user mode, any user application, it results in changing the mode from user to kernel, execute the operating system routine and come back to the user mode. So that is what the last point is saying. System call changes mode to kernel, return from kernel, resets it to user. Some instruction designated as privilege only execute in kernel mode. All instructions that manipulate the hardware essentially are called privilege instructions. And sometimes even people call the translated part of the system call is a privilege instruction, like interrupt instruction, software interrupt instruction, when executed in from the application will result in making a transition from user mode to kernel mode. So this is the diagram illustrating the same concept from the textbook of 𝐂𝐤𝐿. Here we have the user process executing, it encounters a system call, and the moment the system call is generated, a software interrupt is generated, trap is interrupted, mode bit is set to 0, so right, changing to kernel mode. Execute the system call non-preemptively and return back from, that is change the mode bit back from from kernel back to user. So here the convention is mode bit value 0 is kernel mode, mode bit value 1 is user mode. So these are simple transition, simple diagrams showing the transition made from user to kernel. Okay. And then what are the, here I am going to discuss briefly about the functionality of the various modules of operating system. Process manager, memory manager, file manager, device manager, what are the important functions? Later point of time in a separate chapter we are going to discuss the distinction between program and process. Here in a very superficial way I am defining process is a program in execution. It is a unit of work within the system. Program is passive entity, process is active entity. Again detail we will see later point of time. Process uses resources like processor, memory, IO devices, etc. And instructions are executed sequentially one at a time. Multi-threaded process may have more than one program counter per thread. These details will come up again in the chapter of threads. So these are the functions related to process management, like creating and deleting user and system processes, suspending and resuming the processes, providing mechanisms for synchronization, communication and deadlock handling. Like that, memory management related functions, allocation, deallocation, address translation, right, keeping track of which parts of memory are currently in use and by whom, right, all these are the important functions related to memory management. Like that, these are the functions related to file management, which is a logical view of information storage, creating the file, deleting the files, right, directory management and primitives to manipulate the files and directories. All these are the related functions of file system. Like that, the hard disk related activities, mounting and dismounting a disk, free space management, storage allocation, disk scheduling, partitioning, protection. These are the important functions related to disk by operating system modules. And like that, we have protection and security. Protection is basically making the system secure from authorized users when they are trying to access the resources in an unauthorized way. Like I am an authorized user. when I'm trying to access a file with write permission, which I don't have, that is a protection related issue. Security is unauthorized people trying to access the system, like security guard, which is there at the entrance of the college or the institution. Security guard, his job is not to allow the other people who are not authorized to use the campus security, like that. So I can have security measures like login and biometrics, and then passwords and user identifications, etc. So that is about this. And there is another function coming up in most of the operating system, modern operating systems, that is called virtualization. That means in one nave platform of the operating system, you are going to provide other operating system as a application. That is called virtualization. Diagrammatically, you can understand this. Emulation used when source CPU type different from target type. Like for example, here you can see this is a normal scenario of only one operating system, but here I have the hardware and then virtual machine manager, and then I have many virtual operating systems, kernel 1, kernel 2, kernel 3, different operating systems running with different processes. So that is called virtualization, which is another important functions, you can say, of operating system. Now coming to the computer system environments, I can have traditional environment like you are using your JVM, or maybe you can even say personal computing, where you can say that the main important goals of such operating system is convenience and efficiency. Convenience and efficiency. Then I have mobile environments like mobile operating systems. You are using, for example, Android, Apple or iOS, etc. Okay, that is about the mobile environments. So they have the more important goal being like battery power consumption. Client server environments used in network environments. Peer client server, there is something like master slave relationship, but in peer to peer, which is a variation of this, there is no master slave relationship. I don't have to talk much about the cloud computing environment, right? So that is another computing area, computing arena, where basically we can use operating system. Then we have real-time embedded systems or real-time systems. Real-time systems are characterized by the fact that they operate in strict deadlines, strict deadline constraints. All right. Systems that operate in strict deadline constraints are real-time. Hard real-time deadlines are very narrow and very stringent. If you don't meet the deadlines, the system will go to chaos or catastrophic loss or destruction. That is hard real-time system. Soft real-time system, deadlines are there, but wider deadlines, flexible deadlines. That means even if you don't meet the deadline, there is no destruction, there is no loss. Soft real-times like bank ATMs, microwave operations, etc. Whereas missile control system, satellite launching, flight control system, these are all hard real-time systems. So operating systems that work in this environment are called RTOS, real-time operating systems, like VxWare. VxWorks is an example of real-time operating systems. So boys and girls, there are different environments in which different operating systems are used, and depending on the environment, I basically have different, the different goals as such. So here is a brief note on traditional environments. These are all called standalone general purpose machines. Okay, and then mobile environments handled by smartphones, tablets, and extra feature, more operating system features are needed like GPS and gyroscope. Allows new types of applications like augmented reality, etc. And like client server environment, I have a server system through a network that various clients are connected, like as in a distributed systems. Peer to peer, there is no master slave relationship as you see over here. Okay, everybody is equally potential and equally powerful. Cloud computing, I don't have to talk to you. Talk about hybrid cloud, public cloud, and private cloud. I don't have to. And then you also talk about the various kinds of services. Platform as a service, and then infrastructure as a service, application as a service, or software as a service. So this is an environment to show the cloud infrastructure. And lastly, I talked about the real-time systems. So, and as far as operating systems are concerned, there are some platforms that provide free open source. So this is a brief slide. You can take a snap of it if you want at later point of time to be studied. We have Free Software Foundation, which has copyleft GNU public license. And then there is a site also given from GNU group that provides free open source software. Okay. And then finally, I would like to make a mention about the various kinds of important data structures that are used in the implementation of kernel. So as per textbook of Galvin, it is called kernel data structures. By and large, in general, what are the important data structures that are generally used and deployed in the implementation of operating system kernels, in the case of Unix or Linux or Windows, like the various data structures that are used is singly linked list, doubly linked list, circular linked list, right, in many of the operating system data structures. Then in many cases you also use binary search tree, because search performance is order of n, whereas balanced binary search tree performance is order of log n, as you know very well. If the tree is implemented as a skewed binary tree, binary search tree, then the time complexity of the operation would be order of n. Whereas if it is implemented as a balanced binary search tree, then the time complexity is order of log n. Then hash functions or hash maps, that is also a very important data structure or technique used in the implementation of various operating system data structures. And then bitmaps, string of binary digits representing the status of items. So boys and girls, this is what I have in the first part, introduction and backdrop, where we have seen what is operating system, right, and predominantly types of operating system like uniprogram, multi-program, types of multi-programming, and that is preemptive and non-preemptive, and then what operating system can do essentially, brief functionality of various modules of operating system like process management, memory management, file management, storage management, protection and security, and then the brief information about the various computing environments, because the important goals of operating system invariably depends on the computing environment. The goals of traditional computing, personal computing environment are different from the goals of mobile operating system environment, client server computing environment, distributed computing environment, cloud systems and real-time systems. Okay, then finally we have seen what are the important data structures which are used in the implementation of operating system, like most of the time singly linked list, doubly linked list, circular linked list, hash maps, binary search trees, heaps, etc. So this is what I have in this lecture, lecture 1, introduction and backdrop. In the next session, we will see about the operating system services and system calls. Till then, thank you so much. And